6.5 is the graphs of the other four trig functions, so tangent, cotangent, secant, and cosecant. So here we have the graphs of tangent and cotangent. So if you remember, the domain of tangent is that x cannot equal pi over 2 plus k pi, where k is an integer. So basically any over 2. So pi over 2, 3 pi over 2, negative pi over 2, because tangent is y over x, and the x-coordinate at those places is equal to 0, so it would be undefined. So when you look at the graph, that becomes vertical asymptotes. So at every pi over 2, tangent has a vertical asymptote. And then it kind of looks similar to a cubic graph in the middle. In this case, if you look at between negative pi over 2 and pi over 2, it goes through 0, and then it increases the entire time and follows those vertical asymptotes. And then just like the other trig function, sine and cosine, it's periodic, so it repeats. In this case, instead of every 2 pi like sine and cosine, it repeats every pi. So the period for a tangent function, a non-transformed tangent function, would be pi. It repeats every other quadrant. Okay, so this is what the tangent function looks like. This is what cotangent looks like. So the domain of cotangent is wherever your y-coordinate equals 0, you can't have. So for cotangent of x, x cannot equal k pi, where k is an integer. So any integer multiple of pi, so 0, pi, 2 pi, negative pi, that becomes your vertical asymptotes on cotangent. Okay, and then similar idea, it looks similar, but instead of increasing, it's going to decrease in between those asymptote lines. Like tangent, the period for cotangent is also pi, so it's half the length of the period of the other four trig functions, which means if you have some kind of shift in here, if you have something multiplied by your x values, then the period is pi divided by that to get rid of that phase shift. And then all the other shifts and transformations that we've been talking about all year also apply to tangent and cotangent. The biggest thing is to be able to recognize what these look like. Here are the graphs of secant and cosecant. So secant has the same domain that tangent does. All these multiples of pi over 2 make the denominator 0. So therefore, it's undefined on secant. So they become asymptote lines just like on tangent. So one period of secant is two groups of asymptotes, so in between two of these, so one up and one down. This blue graph in the middle is the graph of cosine, so you can see the relationship between cosine and secant. You can see that they touch at the same point, and then these follow the asymptotes instead. So the period of secant is 2 pi, just like the period of cosine. Cosecant, wherever you have a multiple of pi, that makes your denominator 0 for cosecant, so that makes the whole function undefined. So that becomes your vertical asymptotes, just like cotangent. Every integer multiple of pi. So you can see here, you can see sine in this blue to kind of look at the relationship between them. You can see they connect also at negative pi over 2 and pi over 2, but then it goes down or up to follow the asymptote lines. Again, one down and one up is one whole period of pi, of cosecant, and then it repeats. So the period of cosecant is also 2 pi, just like sine. So the only two that have a period that's not 2 pi are tangent and cotangent. They have a period of just pi. Again, all your transformations that we've been talking about all year also can apply to secant and cosecant, but really you just need to be able to recognize what these look like.